Hi, in this question we are given in a triangle ABC, AB is equal to AC, which is 8 centimeter. So this is basically an isosceles triangle, right? So let's draw a triangle. AB is equal to AC. A, B, C. AB is 8, AC is also 8. Okay, we don't know what is the length of BC. We'll figure that out later. Next, a circle is drawn with BC as the diameter. So with BC as the diameter, a circle is drawn which passes through A. So the circle basically passes through A and the diameter here is BC. So assume that this is a circle, although it does not look like one, but still this is a circle. Okay. Now since BC is the diameter, we know the diameter on the circle makes an angle of 90 degree. Hence this angle here comes out to be 90 degree. Point A lies on the circle and BC is the diameter. Hence angle BAC is 90 degree. That means this triangle ABC is a right angle triangle at 8. So if A is the right angle and AB is 8, AC is 8, that means BC will be square root of 8 square plus 8 square. Hypotenuse will be 8 root 2. Right, this is an isosceles right triangle, so hypotenuse will be root 2 times the two equal sides. Fine. Using Pythagoras theorem obviously. Now this is the triangle we have and this is the circle. Since the diameter is equal to 8 root 2, the radius of this circle will be half of 8 root 2, which is 4 root 2. Okay. Let's call this circle 1, C1. Now next, another circle is drawn with A as the center. With A as the center, another circle is drawn which passes through B and C. Since AB is equal to AC, with A as the with A as the center, another circle is drawn which passes through B and C. So let's say this is the other circle. Okay. Now, the area in square centimeter of the overlapping region of the two circles. So if this is first circle and this is another circle, the overlapping region will be, first is this part and the other overlapping part is this part, this whole part. Right? So the orange region plus the green region is the common region between the two circles. Okay? Fine. So we have to figure out the area of this whole thing. Now let's talk about the orange region first. Let's talk about the orange area shaded in orange. Now this is basically the semicircle of the smaller circle with BC as the diameter, right? So area of the circle will be half of the area of the whole circle, which is pi r square, right? So half of pi into, what is radius of this circle? Radius is half of 8 root 2, which is 4 root 2. So 4 root 2 whole square, which is half of pi into 4 root 2 is 16 into 2, 2 cancels out, 16 pi. So area of this orange region is half of the total area of the circle, which is 16 pi. So I'll write this here. This whole area is 16 pi. Okay. Now let's calculate area of the green part. Now how can we calculate area of the green part? Area of the green part can be calculated basically if you consider the bigger circle. This is a sector of the circle, right? And this sector has an angle of 90 degree. So from this sector, if we subtract the area of the triangle ABC from this whole white sector, if we just subtract the area of triangle, we'll be left only with the green region, right? So the area of the green region, the green area is area of the sector ABC minus area of the triangle ABC. Okay. Now what is going to be the area of the sector? The sector makes an angle of 90 degree at the center. So it will be theta by 360, that is 90 by 360 into pi r square. Now what is radius of this bigger circle? The radius is 8. So this becomes the area of the sector minus area of this triangle. Now this is a right triangle, so area of the triangle will be half of the product of two smaller sides, which is 8 square. Okay. So 90 by 360 is 1/4 into pi into 8 square is 64 minus half of 8 square 64. So this becomes 64 goes by 4 16 times. 16 into pi minus 64 goes by 32 times. 16 pi minus 32. This is the area of the green part. Hence the total area, the total required area which is common to both the circles is this, the orange part plus the green part. So this comes out to the orange part is 16 pi and the green part is 16 pi minus 32. So this is 32 pi minus 32. Now taking 32 common, we are left with pi minus 1. So the total required area is 32 times of pi minus 1, which is option B. So option B is the right answer here. Thank you.